Hi guys, I'm Pooja and in this video we are going to dig deeper into vROPs to learn how it is actually working. So let's begin. The topics that we'll be covering will be its architecture, scalability, high availability, design considerations, and in the end, recommendations and prerequisites that you need to keep in mind before deploying vROPs. So let's begin with the first one, that is your architecture. Now, in the center, what you are seeing is the layered architecture of a single vROPs node. Now, vROPs have four types of nodes and all of them share a common architecture, and about which we are going to discuss later in the video. Now, this single node is a complete vROP solution, and because it has both analytics and user interface. Now, by vROPs node, I mean it's a virtual appliance which is a pre-configured operating system with a single application on it. So in our case, that single application is vRealize Operations Manager and the operating system is Linux. So let's understand the functionality of all of these components. Watchdog service is the first component and it is a Python script. Its job is to monitor whether all the necessary vROP services are running or not. So let's say due to some issue, one of the service stops. So at that time, what Watchdog will do, it will try to restart that particular service. So the question is how it is achieving that. It is achieving that by checking two things. And it is doing that in every 5 minutes. So the first thing is that it is checking the process ID file of all the services, that whether they exist or not. Secondly, it is checking the status of all the services, that whether they are in running state or in not running state. Now let's move on to the next component. The second component is the user interface, and it is responsible for the user interaction with vRealize Operations Manager. Now it has two types of user interfaces. One is admin user interface and the other one is the product user interface. So let's start with the admin user interface. Now this interface is present on all the nodes and you can access this interface only by admin user. So what all you can achieve through it is that you can perform all the cluster related administrator activities for which CASA is responsible. That is your cluster and slice administrator. For example, you can take your vROPs cluster offline or online. You can even take your nodes offline and online. Secondly, you can upgrade your vROPs also through this interface. So it not only used to perform administrative tasks, it is also used for performing troubleshooting. For example, you can check the status of all of your nodes, that whether they are down or in error state or not. Secondly, you can check the logs also to find the root cause of the issue. And the last is that you can check the object count of all the nodes and even the metric count also, so that you get to know that whether you need to scale up or down or scale in or out your vROPs cluster or not. And many more things you can achieve through this interface also. So to access this interface, you just have to type this URL, that is https:// your node's IP or FQDN, then /admin. Second user interface is the product user interface, and it is the graphical user interface of vROPs. It is present on all the nodes except for the remote collector, and it can be accessed by any user. It can be admin, local, or AD, etc. Now, what we can achieve through this interface is that we can perform customizations. That is, you can customize how you want to monitor your whole environment and how you want to fetch that data. and much more thing. So how it is doing that is that it makes calls to the controller to access the data so that it can create dashboards, reports, alerts and symptoms, policies, and much more. Now, this UI is not only used for customizations, it is also used for performing certain administrator related actions. For example, you can check the logs, configure adapters that for the sources that you want to monitor, and you can even check the status of your vROPs cluster plus the status of the nodes and many more things. So if you want to access this UI, you just have to type this URL, that is https:// your node's IP or fqdn/UI/actions. In production, it is always recommended to use fqdn instead of the IP. So now one important thing to note is that the last known state of product UI is stored in a small database, and that information is being fetched by the admin UI all the time. So that if your cluster fails or goes offline, or your nodes goes offline due to some issue, then the product UI won't be accessible, but your admin UI will be accessible all the time. So now let's move on to the next component. Next component is the collector, and it is pulling the data from the sources that you want to monitor. It is achieving that with the help of the adapters. Now let's look at few of the examples of such adapters, and let's begin with the vSphere adapter. So here you are seeing is the node architecture of a remote collector. So here we have configured a vSphere adapter to monitor a single vCenter server. If you want to monitor multiple vCenter servers, then you need to configure vSphere adapter for each of them. Now this adapter is providing vROPs with the configuration information which is required to pull the data about the vCenter inventory and its metric data. Secondly, if you want to remediate certain actions, then you need to configure a Python adapter for that. Let's say you want to remediate certain actions to the vCenter server, you need to configure a Python adapter for that, which will provide the vROPs with the information that how to remediate these commands back to the vCenter server, like taking the VM on or off, or performing vMotion, and etc. Next example is the endpoint operations management adapter. This adapter is configured only when you want to monitor your OS. So for OS level monitoring, you configure this kind of adapter. So for that, you need to add an epops agent on each of these VMs that you want to monitor. After configuring that, the vROPs will listen through all of these agents. And like that only, there are other types of adapters also, depending upon what sources that you want to monitor. Now, this adapter contains two things, that is your configuration file, and the other one is the jar file. Now, configuration file contains the information that how it is going to fetch the data from the sources, and the jar file will contain the whole inventory of the sources. Now let's move on to the next component. Next components are GEMFIRE and GEMFIRE locator. So let's start with GEMFIRE first. It is an in-memory data grid, that is, it is making use of the RAM of the nodes, and all of the data is spread across all the nodes. So what it is providing is that it provides the access to all of that operational data which is spread across all the nodes to the vROPs with very low latency. Another feature of it is that we can scale the vROPs cluster as per our needs by adding the nodes. It won't affect the GEMFIRE. It also allows us caching, processing, and retrieval of matrix data. This is dependent on GEMFIRE locator. Now, what is GEMFIRE locator? GEMFIRE locator's job is to locate all of its cluster members. Next thing is that GEMFIRE locator is only present on master and master replica, and it runs as client process on the data node and the remote collector node. Now we are going to discuss about both of them, that how they are working actually, in the later section of the video. So now let's move on to the next component. Controller is the next component, and it is a sub-process of the analytics. It is responsible for coordinating activities between cluster members. It also manages storage as it sends data to the persistence layer. Secondly, it is also responsible for managing retrieval of the inventory of objects. As when the collector collects the data, it will contact the GEMFIRE locator to locate a cluster member. After that, it will send that collected data to the controller of that particular member. Second thing that comes into picture is the GEMFIRE MapReduce function. Now this function allows selective querying and efficient querying of data. By selective querying, I mean that it knows where a particular information about a particular object is being stored. And by querying is that, let's say you want to generate a report on a particular object. You go to the UI, you select a report, you generate a report on particular object. The controller will pull the data from the persistence layer, and that pulled data is thrown to the analytics. There, the processing of the data takes place. After that, the end result will be shown in the user interface. So this is how querying is done. Next thing is that it also monitors the collector's health. How it is doing that is, when the collector sends the data to the controller, it also sends a heartbeat to the controller so that the controller can monitor that heartbeat so that it will know whether the collector is running or not. And it monitors the collector's heartbeat every minute. Another thing that controller monitors is that how long a deleted resource will be available in the inventory, plus how long a non-existing resource will be stored in the database. Now let's move on to the next component. Next is analytics, and it is the heart of vROPs. It tracks the state of every metric and then applies various forms of correlations to determine that whether there are any problems or not. For example, that you have received an alert stating that the workload is high on a particular host system. So, as you know, that workload batch will only get affected if its children, that is the children of the host system, which are VMs, have high contention, high usage, not getting enough resources according to their demands, have low space and low memory, etc. So this is how analytics is tracking the state of every metric and then applying correlations and finding that this issue is there and I should throw this alert. Another thing is that it also performs other tasks, like it calculates metric value. For example, it gives the utilization value of CPU and memory in percentage, in MB, TB, in gigahertz. It also gives the capacity remaining value plus the batch value, etc. Next is dynamic threshold. Dynamic threshold is being calculated after analyzing the environment for a certain amount of time. It can be either 3 months or it can be 6 months, etc. It is a USPA of vROPs. Now what happens is the vROPs will analyze the environment for a certain amount of time and learns what is the normal behavior for a particular object and then sets the value of the threshold according to that. For example, let's take the example of a VM only. Let's say a particular VM's CPU utilization never goes higher than 70% and never goes less than 60%. So according to vROPs, it is the normal behavior for that particular VM. So it will set the dynamic threshold to be in the range of 60 to 70. So if in the future the utilization ever goes higher than 70 or goes less than 60, the viewer-ops will consider it as anomaly and will act accordingly. Next is alerts and symptoms. So as we all know that alerts are composed of either single symptoms or multiple symptoms, and on those symptoms different conditions could have been applied. So what analytics does is it checks the alerts that what all symptoms it contains and what all conditions that has been applied on all of the symptoms, that whether they are true or whether they are false, and then will trigger alerts accordingly. It will also check what all symptoms have been triggered and what all symptoms are not triggered also. Next is the root cause analysis. Now VROPS also finds the root cause of particular issue. Next is it stores and retrieves the metric value also, as it sends the data to store the metric value in the persistence layer and retrieves the metric value from the persistence layer for the calculation. And the last is historical data. Now analytics layer will perform calculations and stores the relationship between objects. It stores the historical data, okay, and it calculates the historical data plus it stores the relationship between different objects. For example, the host is the parent of a virtual machine. A cluster is a parent of host machine, etc., and then stores that data in the persistence layer. Now, analytics also responsible for generating SNMP and SMTP alerts on master and master replica. Now let's move on to the next component. Next is the persistence layer, where all the data is being persisted to the disk. That means all the read and write operations to the database are performed here only. Now, it is important to understand this layer because it has a strong relationship with data and the service availability of vROPs. Now, at this layer only, one more thing comes into picture, which is sharding. Now, you must be thinking that what is sharding? Sharding is a process of distributing data across multiple nodes to ensure that compute, storage, and network load is evenly distributed. Now this layer consists of multiple databases having different functionalities. So now let's look into them. First is the Cassandra DB. Now Cassandra DB is also known as Global DB, having database type Apache Cassandra. Now, the functionality of Apache Cassandra is that it is highly scalable as it allows us to add nodes to the cluster. Secondly, it provides HA, that is high availability, with no single point of failure. And the last is that it can handle large amount of structured data across multiple nodes. Now, this database is present on all the nodes, but it is active only on master and master replica. Here the no sharding occurs, and what all we can store in Cassandra DB is that user access and user roles information, alert definition plus symptom definition, reports template, licensing information, policies, dashboard, and much more. So now let's move on to the next databases. Next databases are Central DB and Alerts or Historical Inventory Service DB. Now both of these databases are the instance of vROPs DB. So let's start with Central DB. Now this DB is also known as replication database, having database type of PostgreSQL, plus at this DB sharding also occurs. Now this DB is present only on master and master replica only when high availability is enabled. Now what this DB stores is the resource inventory information in metadata format. Now the central DB of master and master replica will always be in a sync mode. Let's move on to the next database, that is the alert or historical inventory service database. Now this database is also known as data DB, present on all the nodes, having database type as PostgreSQL, plus sharding also occurs. Now this DB stores the information about alerts and symptoms history, plus history of resource property data and history of resource relationship. Now let's move on to the next database. Next DB is HSQL, which is the HyperSQL DB. It is present on all the nodes, plus it is an in-memory DB, that is, it makes use of the memory of the nodes to store the information. Now this DB is also known as CASA DB, that is Cluster and Slice Administrator, which is responsible for all the cluster-related administrative actions, like taking the nodes offline, taking your cluster offline, or even upgrading your vROPs, etc. So all that information is stored in this DB only. And at this DB, no sharding occurs. Now, the next database is the FSDB, that is the file system database, and it is present on all the nodes. Now, this DB stores the information about all the raw time series metric and supermetric data for the discovery of resources. Secondly, it also stores the collected data from the adapters also, and also the data that has been calculated or generated by the analysis of the data. Now this database has no sharding. Now, vROPs cluster consists of different types of nodes. First is the master node. There can only be a one master in a whole vROPs cluster. Second is master replica. Now there can only be one master replica. Plus this node comes into picture when high availability is enabled in your vROPs. Next is data node. Now there can be multiple data nodes depending upon your requirement. And the last is the remote collector. That also depends upon your requirement, as there can be multiple remote collectors deployed in a cluster. Now let's try to understand the functionality of all the nodes. Now it's time to understand about different types of vROPs nodes. But first you need to know that initially when you'll be creating these nodes, they have no role. At the time when you'll be configuring them, at that time you'll be assigning them the role like master, master replica, or the remote collector. So now let's begin with the first node, that is the master node. Now this node is the first node that you are going to be deploying, plus a single cluster can only have one master node. As you can see in the image that this node have all the components plus all the databases. Now this node also have some critical services running on it, which are NTP server and the GEMFIRE locator. So let's begin with the first one, that is the NTP server. Now this is a network time protocol which is basically used for time synchronization of all the nodes of vROPs cluster. And why we are doing it is because we want all the nodes to have correct plus same time. Now vROPs cluster can have an external NTP server or an internal NTP server. With external NTP server, only master or master replica will require the access to it. And by internal NTP server, I mean that master is going to act like the NTP server for the whole vROPs cluster, and all the nodes will be synced according to the master's time. Now let's move on to the next service, that is the GEMFIRE locator. Now this service is present only on master and master replica. Plus its function is to just tell the vROPs nodes that where the running cluster members are located. Plus it provides load balancing of all the queries. Now let's move on to the next node, that is the master replica node. Now this node can only be one in the whole cluster. Its job is only to provide high availability to the master node. So when we enable high availability to the cluster, this node comes into picture. Let's say master goes down due to some issue. At that time, immediately master replica would come up as a master. So that is why the master node and the replica node will always be in a complete sync mode. That is, its global DB, its central DB, and its alert or historical DB will always be in a sync mode, as you can see in the image also. Plus, in the image you can see that the NTP and the DNS servers and LDAP, that is the AD service, all of them are synced. Now, let's move on to the next node. Now the next node is the data node, and it is a standard role of vROPs cluster, as in the beginning when you add a new node to the cluster, it will be deployed as data node only. Now as you can see in the image that data node have similar components as the master except for GEMFIRE locator, NTP server, and the central DB. So it can also collect the data, process the data, and also perform querying of the data. Now, the basic and the most important job of data node is to provide scalability to the vROPs cluster. Let's say at the moment the vROPs cluster doesn't have enough resources to monitor the current count of the objects. So for that we add data nodes to the existing cluster, and that is called horizontal scaling. Now let's move on to the next node. Now the next node is the remote collector node. Now its only job is to collect the data from the sources and then send the data to the data nodes or the nodes of the cluster. Now we deploy this node so that we can fetch the data from the remote sites, or if we want to separate the processing load and the collection load. Now this node have only two components. One is the collector and the other one is the admin UI plus the watchdog service. Now, this node doesn't provide failover. Like if the data node fails, then the collection plus the processing load of the failed data node will be taken over by the other nodes, even if HA is not enabled. But the same doesn't happen with the remote collector. If one of the remote collector fails, the data it has been collected won't get collected. Plus, the remote collector stores the data, or you can say keeps the data for a certain amount of time, and after that time it will drop that data. So that time depends upon the size of the remote collector. And that's it. Now let's understand the data handling in the multi-node cluster. vROPs can have a single or a multi-node architecture depending upon your requirement. Right now we are going to see how data handling in a multi-node cluster can take place. So there are two terms that you need to understand. First is GEMFIRE clustering and the other one is GEMFIRE sharding. So GEMFIRE clustering is an in-memory clustering and distributed cache which has its own internal transport bus and which provides balancing of CPU and memory consumption across all the nodes. In the previous section of the videos, you have seen that GEMFIRE sits on top of controller, analytics, and the persistence layer. So you can assume them to span across the whole cluster, rather than to assume them as an individual component of an individual node. Now the features of GEMFIRE are, first is elasticity and scalability. That is, you can increase the cluster by adding a node to it depending upon your requirement or your demands. So in a single vROPs instance, you can add up to 6 Excel nodes. Second is reliability, that is, when GEMFIRE H is enabled, it will create a backup copy of all the data and stores it in the analytics cache server and in the persistence layer. Third is availability, that is, even if GEMFIRE H is not enabled and some failure occurs, then all the other nodes will take over the failed service and the load of the failed node. And I'm assuming that the failed node is not the master node. Now the last one is data partitioning, that is to distribute data across the node into a unit that is called the bucket. Now here GEMFIRE map reduce function is used, which is a data aware query and which also supports parallel data querying. After all that, the result is then returned to the coordinator for the final processing. Now, GEMFIRE sharding is a process of splitting data across multiple GEMFIRE nodes in various partitioned buckets. Now, it is in conjunction with controller and locator service balances the incoming resources and matrices across all the nodes. Now, it should be noted that data is sharded per resource, not per adapter instance. Now, the data is sharded in both analytics component and the persistence component. So, the analytics component is known as GEMFIRE cache sharding, and at the persistence layer, it is known as GEMFIRE persistence sharding. Now, just because data is present on the GEMFIRE cache of a particular node, then it doesn't mean that the data shard persisting will happen on the same node. So the chances of that is only 1 by n, where n is the total number of nodes. In this section, I'm going to show you what I was talking about in the previous section, that is data handling in multi-node cluster. First, I told you that GEMFIRE sits on top of controller, analytics, and the persistence layer. So you can span them across the cluster just like that. It has been spanned across the cluster. So on controller level, GEMFIRE applies its map reduce function. On the analytics level, it will have a GEMFIRE cache for storing the sharded data. And on the persistence layer, it has GEMFIRE persistent sharding. So this is what I was talking about. Now let's move on to the next section. Now let's look into the scalability feature of vROPs. The advantage of GEMFIRE based cluster is that it provides elasticity, and the size of all the nodes of the vROPs cluster should be of same configuration. Let's say your environment is growing and you want to scale out your cluster, so you can achieve that by adding data nodes to it. After the addition, it is recommended to rebalance the disk because it is going to reshard the data. And this is a disruptive operation because it does need downtime. Secondly, it is also recommended to rebalance the GEMFIRE also, because it is going to rebalance the compute and network load over the whole cluster. So it is achieved by repartitioning of the buckets. Now, how much time it will take depends upon the amount of data that is being stored in the FSDB and how big is your cluster. Now, let's say you want to scale in your cluster. So you can achieve that by removing a node from a cluster by taking it offline. Now, the removal of data node from a cluster which has HA disabled will result in data loss on that node. So it is generally recommended to avoid removal. Now let's look into the high availability feature of vROPs. Enabling HA makes two major changes. First is creation of master replica, and the second is that the controller layer is going to duplicate all the sharded data into both GEMFIRE cache and GEMFIRE persistence layer. So how we are going to create the master replica? To achieve that, there are two ways. First is that you can either select one of the data nodes from the existing ones to whom you are going to give the role of master replica, and the other one is that you can deploy a new node as master replica. So the job of master replica is that when the original master fails or goes down, it will take the role of the master. So how it is achieving is both the nodes are in sync mode. So there are three databases that are always in sync. One is Cassandra, second is Central, and the third one is Alert or Historical Inventory Service Database. So now let's look into data duplication. Now HA duplicates all of its incoming data so that it has two copies of it. One is primary and the other one is secondary for the failover. If a node is down, then the secondary data will not be created unless and until the original node is removed permanently. When the failed node becomes available again, the data synchronization with other cluster member begins, and after the completion of synchronization, the node will return to active state again. Now we are going to see the process of incoming data and how it is going to handle the creation of new object in an HA configuration. Right now, the adapter is fetching information about a new object from this vSphere environment. So collector is receiving the information of the object, that is its matrix and its properties, and after that it is going to create a new object, that is it is going to send the information about it to one of the node's controller. So here I'm considering the object name is R3 and its information is being sent to the controller of the master node, that is this one. After that, a new analytic item is being created in one of the node's analytics. So that information is being kept in the GEMFIRE cache of that particular analytics. So in this case, it is going to be sent to the master replica node's analytics. That is there the analytic item is being created. That is R1. Similarly happens for its duplicate copy. That is R3 hash, that is being created in the analytics of master node. Now after that, this information is being sent to the persistence layer of some other node. So the primary data of that particular object is being sent to the data node, that is being stored in its FSTB and its historical inventory service, and its secondary data is being sent to the master replica's persistence layer, where its information is being sent to the FSTB and historical inventory service. When it is being sent to the controller, it also stores the information about that a new object has been discovered in the central DB plus in the global DB. Now let's look at the non-HS scenario of when a new object is being discovered. Right now the adapters have discovered a new object which is present in this vSphere environment, and the collector is receiving information about the object's matrices and its properties. After that, the collector will send this information of the object to the controller. I mean the controller of one of the nodes. In this case, it's the master's controller. After that, the master will update its global DB, also its central replication DB, that a new object has been discovered, and then sends that data to one of the node's analytics component, that is this one in this case, where the data is being cached, and after that it will send the information about that object to its respective persistence layer, and there it is then stored in the FSDB and the historical inventory service DB of that particular node. Now it's time to talk about design considerations that you need to keep in mind before sizing your vROPs. So the first question that you should ask is, what's the number of objects plus the type of objects that you want to monitor, and also the number of matrices that you want. Next is whether or not you want HA, because as you know, once I enable HA, it will create a secondary copy of each object. So at the moment, if your cluster is supporting 60,000 objects, after enabling HA, it will be reduced to 50%, that is 30,000. Next is whether or not you want remote collectors. Then how many users are going to be accessing vROPs UI at the same time? Now, the next question is, how big is your environment that you want to monitor? Whether it is present on different geographical locations or not. Then whether you want OS level monitoring of your VM, because for that you need to deploy Endpoint Operations Management Agent, which is in short known as EPOPs agent. Because when you deploy EPOP agent on a particular VM, it will add three new objects to your vROPs. One is your OS instance, then EPOP agent, and the last is your service. Plus, for the communication of EP agent with your vROPs, you need to deploy a separate load balancer. And the last is how many adapters you want to configure. Let's say you want to monitor SQL or Exchange or Active Directory, etc. Then you need to configure adapters for them. Now we are going to see different deployment examples. So the first one is that I have multiple vCenter in a single data center. In that case, I'm going to deploy my vROPs cluster in that data center only. And for each of the vCenter servers, I'm going to deploy a separate adapter for each of them. Now, the second example is when I have multiple vCenters at remote locations. So what I'm going to do is I'm going to deploy my vROPs cluster into the main data center, and on the remote data centers I'm going to deploy RCs for them to collect the data from those data centers, and it will throw the data to my vROPs cluster. Still, for each of the vCenter server I have to deploy a separate adapter for them. So the third example is that there are two main data centers with multiple vCenters. So in that case, I'm going to deploy different vROPs cluster for each of the data centers. And each of the data centers, I'm going to deploy different vCenter adapters for each of the vCenter servers. Now it's time to talk about our last section, that is recommendations and prerequisites. So let's start with prerequisites. First is that each node should be located on same VLAN and IP subnet. Second is the bandwidth should be 1 Gbps or more. Third is if your vROPs is present in a highly consolidated cluster, then you need to configure resource reservation for it, because vROPs is a highly resource intensive tool. Then, if you want to monitor OS level instance of your VM, then you need to deploy endpoint agent for it. And after deploying agent, you need to deploy a separate load balancer for its traffic. Then, the latency between the analytics nodes is supported is 5 milliseconds only, and not more than that. Otherwise, the packets will drop. Then the cluster must have at least n plus 1 host, where n is the analytics node. And all the nodes should be of same configuration, that is, the size of all the nodes should be of same configuration. Now, the recommendations are that nodes should be on same type of storage. They should use DRS anti-affinity rule, or they can also use storage DRS anti-affinity rule, so that they are separated to different data stores, plus they should present on different hosts always. Next is the bandwidth should be greater than or equal to 10 Gbps for better performance. And last is that the latency for analytics node and between remote collector should be not greater than 200 milliseconds. So this is the end of the video, and I hope you learned something from this video. For any queries, you can always contact us. Thank you so much.